All right, welcome to the second part of the language unit. Let's dive right in. All right, so hopefully you watched the movie about Jeannie, the young child who was kept in severe isolation for most of her childhood. Um, Jeannie is an incredibly unfortunate case study, but she came into the psychology world right at a very important time. The debate was literally raging between Skinner's followers and Chomsky's followers about how we learned language. Remember, Skinner was saying that language is behavior like any other behavior. It's simply verbal behavior. Language is learned through simple reinforcement and punishment. Chomsky was saying, no, language is special. Language is something that we have an innate, inborn ability to learn. And then along came Karl Lenneberg, who said that Chomsky's right, but we need to be exposed to language during a critical period in our development. If we are not exposed to language, then during that critical period, we will not develop language. So the results from Jeannie's case study would support Lenneberg's idea of the critical period. Jeannie was not exposed to language during her critical period of development, and despite everyone's best efforts, she did not learn full on human language processing. So, what about normal, healthy human language development? Let's talk about that a little bit. Usually, before the first year of life, very small infants, children, they babble. I'm sure you know what I'm talking about. Maybe you have your own child, or maybe a young niece or a young nephew. They love to babble. They're kind of just realizing that they have these vocal cords and they can make a lot of noise, and they're just happy to try it out. They're just kind of seeing what the human vocal system is capable of. It's kind of like finding a new toy and just figuring out what it does. About 1 year of age, this is when children enter the one word stage. They usually learn their first word around this time. And we're talking specifically about language production here, not language comprehension. So, around 1 year of age, this is when children are able to produce one word at a time. Around a year and a half to 2 years, this is when children gain the ability for telegraphic speech. So, speech refers to really short phrases, 2, 3, 4 words long. Instead of saying a grammatically correct, polite sentence like, I would like my juice now, please, a telegraphic form of that sentence might just be, want juice now. So 3 words, very telegraphic speech, something that you might see in a telegram, if anyone knows what that is. Around 2 years of age, this is when the vocabulary explosion starts. Now, the vocabulary explosion is a literal uh, exponential growth in the size of a young kid's vocabulary. So the number of words that they know grows very, very fast. At the height of the vocabulary explosion, the kids are learning on average 7 new words per day. Now, that's pretty spectacular. If you think about it, I would be hard pressed to learn 7 new words every single day, but that's what these kids are doing, and it's pretty impressive. Around 1 year of age, we become specialized language learners. We get specialized in whatever language it is that we're exposed to. If we grow up in a monolingual household, that's going to be just one language. A bilingual household, it's going to be two languages. And we become specialized to those two languages or that one language, whatever household it is we grow up in. And we do this at the detriment of other languages. Other languages that we're not exposed to in our early years, they tend to sound like they just run together. So if you are not a fluent German speaker and you hear the German language spoken, it's kind of hard to tell where the boundaries between the words are. It's hard to tell what's one word and where the spaces are. It just kind of runs together. The same would be true for people who aren't fluent in English. If they were listening to me talk right now, it might sound like there's no breaks between the words. So that's kind of the typical normal, healthy language development course that we take. Obviously, Jeannie did not get that ability to go through the normal language development process. Her progress was derailed quite severely. Now, I want to briefly touch on something called the Sapir-Whorf hypothesis. And I'm willing to bet a fair number of you have had some exposure to this. You might not know it as the Sapir-Whorf hypothesis. The Sapir-Whorf hypothesis is the idea that the language we speak has a huge influence on our ability to think and our ability to behave, the behavior that we engage in. So, this idea is often exemplified by this observation that Eskimos, who live up north in the Arctic, have many words for snow. And because they have many words for snow, they are able to perceive snow differently than someone who is not an Eskimo. So the idea is that because Eskimos have a language that is focused on snow, they perceive the Arctic environment in a different way than someone who doesn't speak the Eskimo language. Well, just a couple other examples from other cultures in the world. The Sami people of northern Scandinavia up in Lapland, they have 480 words for snow. They also have over 1,000 words for reindeer. Reindeer are very important to their culture. It's a source of food. They're beasts of burden as well. The Scottish people, the Scottish Highlands, they have 421 words for snow. So Eskimos are not unique in having many words for snow, but they're often the example that's given in support of the Sapir-Whorf hypothesis. All right, so do we have any data to support this idea that the language we speak determines our thought and determines our behavior? Well, the answer is no, with a really small asterisk. So that really small asterisk can be seen in a couple really small areas. So remember, the Sapir-Whorf hypothesis is saying that the language you speak has a huge influence on how you perceive the world and how you behave in the world. Well, we just don't have any evidence to support that. Eskimos have a lot of words for snow, but we don't have any evidence that they act differently around snow or perceive snow differently than someone who's not an Eskimo. We just don't have that data. It doesn't exist. The studies have been done, but the results do not support that idea. But, and this is where that really small asterisk comes in, there are some exceptions. There are some ways that the language we speak can influence how we perceive the world around us. One example at the top of the slide there, gendered nouns can influence our perception of objects. So if you're familiar with gendered languages, these are languages that have gendered pronouns, or not gendered pronouns, gendered articles. So Spanish or German, those are both gendered languages. Nouns are either masculine, feminine, or neuter. And a great example used in this research was bridge. I do not know the Spanish or the German word for bridge off the top of my head, but I do know that in one language it is feminine and in the other language it is masculine. And now when they asked people who spoke either Spanish or German to describe bridges, they responded with stereotypical adjectives that were either stereotypically masculine or stereotypically feminine. So if they spoke a language where the bridge was a feminine noun, they tend to describe the bridge as beautiful, elegantly designed, shapely, things that are stereotypically feminine adjectives. The exact opposite case occurred in languages where the bridge was a masculine noun. They said the bridge was sturdy, it was well built, It could hold a huge load. It was very strong. Stereotypically masculine adjectives. So in this small way, gendered languages, that can have a very small influence on how you perceive certain objects. Another very small example is color perception. Depending on the language you speak, you group colors differently. So if you take a look at the right side of the slide here, we have three colors. We've got chip B, which is definitely green, and we've got chip D, which is definitely blue. And then we've got chip C here sitting in the middle, which depending on how you group colors could be either green or blue. I'm sure some of you are looking at this and you're saying, well, that's obviously blue, or you're saying that's obviously green. Depending on the language that you speak, that will have some influence on how you make this determination. Most English speakers would throw chip C in with chip D. They would say this is blue. Most Tarahumara speakers, which is a native tribe in northern Mexico, would group it in with the green chip. So color perception and our gendered languages, gendered nouns, that's really the only two areas where we have found evidence for the Sapir-Whorf hypothesis. Again, these are very small areas of life, but the original idea was that your entire worldview, how you interact with the world around you, how you perceive the world around you, these are all heavily, heavily influenced by the language you speak. And we just haven't found the evidence to support that idea. All right, so let's move on and talk about aphasia. Aphasia is a very broad term for a language disorder, and this can be a language disorder that affects comprehension, so how you understand language. It can also be a disorder that affects production, so how you produce language, and it can also be a disorder that affects how you use grammar. The two areas that have been studied most are comprehension and production. Grammar use aphasia is not so well studied. It's a lot more rare. So we're going to focus on comprehension and production forms of aphasia, and we'll briefly touch on aphasias that influence grammar use at the end. So let's jump into comprehension aphasias. And we're going to start with Wernicke's aphasia. So Wernicke's aphasia is named after Carl Wernicke. Carl Wernicke had a patient who had some pretty severe comprehension difficulties. So Wernicke's patient could produce speech just fine, but that speech was not related to anything that was being talked about. If they were asked a question, their answer was just complete babbling. It was coherent words, and oftentimes it was even grammatically correct, but it just was not a direct answer to a question. It had no relation to what the people were talking about around this patient. So it was pretty clear that there's some comprehension difficulties here. The patient is not understanding the question, they're not understanding what is being spoken to them, and they're not really putting together speech that makes a whole lot of sense in context. So there is a video that I have linked on the Canvas website. Go ahead and click that link and you'll see a video of a patient who is suffering from Wernicke's aphasia. And you can see pretty quickly, like, this person likes to talk and they're intelligible. They're putting words together that you can understand, but pretty quickly you realize this guy's not making any sense. Wernicke's aphasia is also called receptive aphasia. And upon Wernicke's patient's death, Carl Wernicke performed an autopsy, and he found some pretty severe damage in this patient's temporal lobe. So taking a look at the brain here, we've got the frontal lobe here, we've got the occipital lobe back here, we've got the parietal lobe up here, and then right where this red dot is, we've got the temporal lobe here. So the red dot is kind of towards the top of the temporal lobe. And this is right where Wernicke saw all that damage. That's what we refer to as Wernicke's area. So this is pretty good evidence that this particular part of the brain has a pretty major role in our language comprehension abilities. So that's Wernicke's aphasia, and this is comprehension difficulties, which is in contrast to Broca's aphasia, which is production difficulties. So Paul Broca was a famous neuroscientist, and he had a patient who went by the name Tan. Tan is not this person's name, but it was the only syllable, the only word this person could produce. They had some pretty extreme difficulties producing language. So Paul Broca's patient Tan, he suffered a stroke, and after that stroke is when these production difficulties arose. And literally, Tan could only repeat that word over and over and over again. And this was very frustrating for Tan because Tan had normal, or at least close to normal, comprehension abilities. So Tan could understand the words being spoken to him, and he knew how to respond, but he just couldn't. He found it extremely difficult to get the right words out. So upon Tan's death, Paul Broca performed an autopsy, and just like with Carl Wernicke and his patient, Paul Broca found some pretty extensive damage in the brain. So here we have another cross-section of the brain. We've got the frontal lobe, and this is where we find the damage in Tan. And this area of the brain went on to be known as Broca's area. So we've got Broca's aphasia, and go ahead and watch the video that's linked in the Canvas course website. That is a video of a person suffering from this form of aphasia who can't get words out. So we've got Broca's aphasia, which is difficulty producing words, and we've got Wernicke's aphasia, which is difficulty understanding words. So Wernicke's aphasia and Broca's aphasia, two very different types of aphasia. Again, Wernicke's aphasia is difficulty understanding or difficulty comprehending. Broca's aphasia is difficulty producing. So for Wernicke's aphasia, this is often harder to recover from. And it's harder to recover from because unfortunately, patients are often unaware that they're suffering from an impairment. So again, they can produce speech fairly normally, but that speech is unintelligible. It's not making sense. They're just kind of running sentences together, having no relation to what's going on around them. So people who suffer from Wernicke's aphasia will often get very frustrated because they think they're making sense. They think that they are answering questions. They think that they're participating in conversation, but in reality, they're not, and they don't realize it. So it can be very frustrating for them because they think it's other people around them that are suffering from some form of impairment. Broca's aphasia, we usually see people respond pretty well to these types of treatments. So people with Broca's aphasia are painfully aware that they are the ones suffering from an impairment. They know the words. They just can't get them out. It's like constantly suffering from a tip of the tongue state where you just can't quite get the word out of your mouth. So people with Broca's aphasia, painfully aware of their impairment, they usually jump excitedly into forms of therapy and treatment. And if you click that video there, I've got a short video of a young woman who experienced a stroke when she was 19 and went on to make a video every single year after her stroke anniversary. And you can see a pretty impressive improvement in a short number of years. So Broca's area and Wernicke's area, this brings up the idea of localization, the idea that there's a specific part of the brain that can be attributed to a specific ability. Broca's area would be language production. Wernicke's area would be language comprehension. All right, so let's talk about written language. So far, we've been focusing on spoken language. Every single language on this planet has a spoken version. There are very few languages that actually have a written version. And this is for a very good reason. Spoken languages are learned more or less automatically. As long as you're exposed to language at a young age, you are going to pick up language. And doesn't matter what that language is, you will learn it. We do have some pre-programmed abilities to learn languages. Learning a written language takes a lot of intentional effort. You may not remember this, but I guarantee there was a time when you were much younger when it took you a lot of effort to learn how to read. This is because you have to learn many different explicit associations between letters and sounds, between letters and phonemes. You learn that specific letters make specific sounds. And that's not something that you can just pick up on. That's something that you have to put a lot of effort into learning. That's why we spend so much time and effort in school, especially in the early years, teaching kids how to read, because it's not something that comes natural. It's not something that comes easy either. All right, a couple examples of written languages. Most written languages are developed over many years. They change over the years as well. You can't point to a specific person or a specific time when a written language was developed, but we do have a couple exceptions to that. Two of those exceptions are listed on the slide. The Cherokee, the written version of it, was created by a man named Sequoyah in the 1820s. It was sort of his attempt to assimilate into the English settlers who were slowly and forcefully encroaching on Cherokee land. Another example would be Hangul, which is the written version of the Korean language. It was created in 1443, and it was the king's gift to his people. He wanted to be remembered for something positive, so he developed this written language system and bequeathed it to his people. The Korean language, the written language, is unique in that there is a one-to-one relationship between a written symbol and a sound, so a syllable. If you are familiar with the English language, you know that's not quite the case. Letters can sound very differently depending on the words that they are in. So, how do we read? Let's talk a little bit more about written language. So, we move our eyes in what are called saccades. I've got a very short video you can watch on the Canvas website if you would like. This video is using eye tracking software to track where someone's eyes are as they are reading a sentence. So a saccade is a very quick, rapid movement of where we are putting our gaze. A fixation happens in between saccades. A fixation is when we actually focus on a part of our visual field. So we've got saccades and fixations. And these saccades are kind of jumping all over the place, and a fixation is wherever we actually focus on something. And fixations are usually very brief. We're talking milliseconds here. Poor readers have more regressions than proficient readers. A regression is a saccade back to a word that we have already read. So if you're reading this sentence here, poor readers have more regressions than proficient readers. A regression would be jumping back to this first word, jumping back to the second word after you've already read it. All right, so we fixate on a very small portion of what we actually read. we don't fixate on every single word in a sentence if we're reading that sentence. We fixate on roughly 80% of content words. Content words would be nouns or adjectives or verbs, important words, kind of the meat of a sentence. But we only fixate on about 20% of function words. So like grammar words, the, to, and, those types of words. Words that serve a grammatical purpose, but aren't really the meat of a sentence or anything like that. So if we're only fixating on 80% of content words and 20% of function words, we are skipping over a lot of words. So how is it that we're actually pretty good readers, given that we don't actually look at a lot of the words we read? Well, this is where top-down processing comes in. If you remember back to the sensation and perception unit, top-down processing is our ability to fill in the blanks. It's our mind's ability to come to conclusions based on the context and based on prior expectations, based on prior experience. So our top-down processing ability allows us to fill in the gaps of what we've sort of skipped over with those saccades. A couple examples of this, of how powerful our top-down processing abilities are. You may be familiar with something like this. This is kind of one of those chain emails you might see every now and then. According to research at Cambridge University, it doesn't matter in what order the letters in a word are. The only important thing is that the first and last letter be at the right place. The rest can be a total mess, and you can still read it without problem. This is because the human mind does not read every letter by itself, but the word as a whole. That's more or less true as long as you have most letters there and you have some sort of context to put it in. Your top-down processing is going to do a pretty good job. One more example, see if you can spot the mistake here. Please read the words as you see them. Maybe some of you have seen this before, but there's actually two thes. Please read the words as you see them. So again, our top-down processing skips right over one of the thes because it's not something we're expecting to see. All right, let's go ahead and stop this video here and get the second one loaded up.